Okay, guys, this week I really wanted to devote to figuring out the age of things, how old things are. Last week we spent mostly looking at fossils and different types of fossils, and as we go along, we'll look at more fossils too. We'll look at dinosaurs and early mammals as we get further along. But this week I largely want to devote to figuring out how old things are. Many of you have probably heard of radiocarbon dating. We'll talk about that later in the week. But there are other ways of figuring out how old something is. And when it comes to geology, when it comes to fossils, radioactive or radiocarbon dating anyway is not all that useful. And that's something that we'll talk about more as we get into it. So the first way that we could put the age of something, or find the age of something, is this concept of relative dating. Relative basically means, well, comparing. And we might not know exactly how old the object is with this idea of relative dating, but basically we're taking the age of something and we're comparing it to something else. So the age of something compared to the age of something else. A very simple example would be, well, I am obviously older than you. You are obviously older than a newborn baby, right? Your grandparents are older than me, right? So we can figure out how old things are roughly with this idea of relative dating. We compare the age of something to the age of something else. And we could do this with rocks, specifically sedimentary rocks. So when we're talking about this idea of relative dating, for one thing, we're usually talking about sedimentary rocks. Well, sedimentary rocks usually form in layers, and we can assume that we have the youngest rocks at the top and the oldest rocks at the bottom. This is what's called the law of superposition. It's a fairly obvious idea, but it did take people a surprisingly long time to kind of figure it out. So when we're talking about undisturbed sedimentary rock, by undisturbed I mean sedimentary rock that hasn't been like folded or tilted or faulted. In undisturbed sedimentary rock, the oldest rock is at the bottom. And the rocks are younger toward the top. So we can put things in order, we can put things in sequence, and we can figure out which rocks are older and which rocks are younger. And in this sequence, well, we know that the bottom rock layer has to be the oldest, and the top one has to be the youngest. Which also means that if this is the oldest, and let's maybe label this 1, then the limestone layer above would be the younger than 1. And then we have 3, and then the youngest layer would be layer 4. So we know that 2 has to be younger than 1, 3 has to be younger than 2, 4 has to be younger than 3. We have no idea how old they exactly are, but we know that compared to each other, 4 would have to be the youngest, 1 would have to be the oldest, 2 and 3 would be in between in order. Geologists often have to try to figure out, well, what are the rock layers underground? And what they'll often do is combine this idea from 3 different locations. And in this diagram, we have the rocks from location 1, we have the rocks from location 2, and location 3. Usually what's done are holes are drilled in the ground, and the rocks that come out of those holes are analyzed, and we can put together a sequence like this. And from the 3 different locations, we can put together a complete cross-section. So if we were to draw lines going across, we have the shale layer, we have the limestone, conglomerate, siltstone, sandstone, shale layers, more limestone, sandstone going toward the top. And again, this would be our oldest layer. This would be our youngest. And we could go and rank them by age order. 1 would be the oldest, then 2, 3, 4, 5, 6, 7, 8 different types of rock in the sequence. But the oldest always at the bottom, and then getting progressively younger as we go up. Things get more complicated when we start having disturbances in the rock layers. Disturbances might be caused by faults, folds, tilts, or igneous intrusions, which we see here too. Magma basically melting its way through the sedimentary rock. But when we have these disturbances, well, one thing that we can learn from them is that the fault has to be younger than the rock that it cuts across. So if we take a look at this sequence of rocks, these are sedimentary, and we can see where they once lined up, but the rock has been faulted, cracked and displaced, or cracked and moved, shifted. And we talked about faults a bit when we did earthquakes. In order for the fault to cut across all of these rock layers, the fault has to be younger than the rocks that it went across. So in this case, again, our oldest rock layers are going to be at the bottom, and we're going to go 1, 2, 3, 4, but now our fault is going to be feature 5, which would be the youngest event in this sequence. If we take a look at the next one, here we have, again, a sedimentary sequence of rocks stacked horizontally. We call this original horizontality in geology. Anyway, our oldest are going to be at the bottom, and we're going to go 1, 2, 3, 4, but now our youngest event is going to be the intrusion. That's magma, or at least solidified magma, that's melted its way into the sedimentary rock. So the intrusion has to be younger than the rock that it goes through. And something, if you remember back to when we did rock types, are these little hatch mark lines on the boundary between the magma and the sedimentary rock, or the igneous intrusion in the sedimentary rock. And if you remember back to that means contact metamorphosis, which means that these sedimentary rocks are being altered or changed into metamorphic rocks. Common regions question. So here we have limestone. Here we have some igneous material. Maybe it's basalt or something, or a granite would probably be a better choice. Coarse-grained igneous rock. Yeah, let's say granite or maybe gabbro. Anyway, the heat from the magma alters the limestone and maybe converts it into marble along this contact. Over here, where we have shale and magma coming together, we might get slate. Okay, so contact metamorphism. That was something we talked about back in the fall. Anyway, the intrusion has to be younger than the rocks that it cuts through. Here we have folds and tilts. This is due to tectonic forces. And whenever we have folding or tilting of rock layers, well, that has to be younger, again, than the rocks that were already there. So if the rocks are not tilted or folded, they have to be older than the fold or the tilt. The fold or the tilt is going to be the youngest event in those sequences. Now there's something else in geology called an unconformity. Kind of a funny word, unconformity. Well, to conform means to be like everything else. And in geology, an unconformity means, well, it's something different. An unconformity represents a surface of erosion. And we did a whole unit on weathering and erosion. This means that there's a gap in the rock layers. There's rock missing. So at some point, some rock layers were exposed to the surface, exposed to the forces of weathering. The rock was broken apart, eroded away due to wind or running water, even glaciers. And then new sediment was deposited on top of that. And what this means is that we have a gap. So if we look at the formation of an unconformity, and there are different types of unconformities, but we'll just look at one common example type. Well, here we have sedimentary rock layers. So here we have formation of horizontal rock layers. So we have sediments being deposited horizontally in order. Again, we would have our oldest at the bottom, getting younger toward the top. And that's pretty simple, right? Then maybe we have some tectonic forces. Maybe we have convergence, creating folding. And with that folding, we get uplifting because now we have mountains being formed. So we have uplifting, and at the same time, folding happening. Then we have erosion. And I'll say / weathering. The combination of weathering and erosion carries away the upper parts of this, basically chops it off, cuts it off. And we have an erosional surface now, where the top has been weathered and eroded away. We have missing rock, and now we have a gap. And then we have new deposition occurring. And the formation of new rock layers. The formation of new rock layers. So we have some material being removed by weathering and erosion, and then we have new material being deposited on top of that. Our unconformity, and unconformities are often shown with a squiggly line like this. Our unconformity on a diagram, or on this diagram, would be right there. That's our unconformity. An unconformity represents not just missing rock, but also a gap in time. It's not that time changed or there was some problem with the universe and time is different. But what we mean is, if these sediments, the bottom layer was the oldest and formed first, and then they get progressively younger, well, we lost a record of the time period. We don't know how long the weathering and erosion occurred for. It could have occurred for 1,000 years, or maybe 1,000,000, or maybe 100 million. We don't know. So we don't know how long the weathering and erosion occurred for. It could have been a short period of time or a very long period of time. There's no knowledge of how long that weathering and erosion occurred for. So the unconformity represents something lost. We lost a record of what had happened during that time of weathering and erosion. So sometimes it's referred to as a gap in time. All right, I think unconformity is a good place to stop for today. And again, we'll continue with geologic dating throughout this week. So how do we figure out what's older? How do we figure out what's younger? And we're going to continue with this idea of relative dating in the next video. And then later on, we'll take a look at radioactive decay and how we could use radioactive decay to figure out how old Earth materials are. So all for now, and we'll do another video on relative dating.